Welcome back, everyone, to another edition of the Prove Me Wrong podcast. As always, I'm Pete Lieb. Over the past couple of years, interest in the space program and space exploration has really ignited once again. Recently, President Donald Trump has issued a challenge to NASA to return to the moon by the end of this decade, into the 20s, and Mars by the 2030s, somewhere in that range. Entrepreneurs like Jeff Bezos, Elon Musk, they've built their own space exploration companies with the goal of making those future trips more affordable, ultimately more profitable. And there is a lot to be learned by venturing out. I think most people would believe that there are still things we can learn through exploration that we can't learn simply sitting behind a telescope. And it is in the human nature to explore, right? But honestly, at this point, the vast distances between one body to another, one solar system to another, simply doesn't make it overly feasible right now to send out humans into space. And we're at a time now in our evolution where maybe the technology has allowed us some luxuries of not having to. Maybe we can go with some unmanned spaceships, some robotics. And to discuss the state of the space program with me today and help explore this topic is my guest, Mr. Rod Pyle. Rod is a space author, journalist, and historian who has authored 17 books on space history, exploration, and development for major publishers and NASA. Rod is the editor-in-chief of the National Space Society's quarterly print magazine Ad Astra, and his articles have appeared in a number of publications, including Live Science, Futurity, Huffington Post, Popular Science, and Wired. Rod has also produced or consulted on a number of space documentaries for the History Channel, Discovery Communications, and National Geographic, as well as several known television shows, and is currently a consultant on the Nat Geo documentary for Tom Wolfe's iconic book, The Right Stuff. So very learned, incredibly experienced, a great guest for me. You can find Rod online at pylebooks.com. You can also find his 17 books on Amazon.com as well. So thank you, Rod, for making the time to join the podcast today.
Thanks for having me. I appreciate it.
Well, let me start with you. You're obviously very accomplished in the field. You've done a lot. What was the spark that ignited that curiosity? How did you get started doing what you're doing now?
That goes back a long way.
Yeah.
So I was born about a year before NASA was, in the late 1950s. So I grew up during the space race, and it was an amazing time to be alive if you were interested in that kind of stuff. So while my friends were out trying to collect player cards for football and baseball, which is what you did then, the
right.
NBA wasn't really a thing yet, I was enamored of the astronauts of the space program, and I really became aware of it kind of in the later stages of the Gemini program, which was the two-man capsule that went up to work out the dynamics of how we were going to get to the moon with Apollo. And those were moving really fast. They were launching sometimes as close as a few weeks from each other. And we were accomplishing spacewalks and learning how to work in space during EVAs or spacewalks, and learning how to dock and rendezvous a dock and so forth. And these were all things that we thought we'd need to get to the moon. In parallel with this, they were developing the Apollo program. So by 1968, NASA had come to this juncture where they realized because this whole time we had been trying to beat the Russians from Sputnik
right.
in 1957 onward. We wanted to show that we were as good or better than they were at technology, because, Apollo, there's this kind of common sense that Apollo was this mandate by Kennedy because he loved the idea of technology going to the moon, which isn't the truth at all. It was a geopolitical contest. There was a lot of competition over these non-aligned nations, and would they go with communism or would they go with democracy? And this was Kennedy's way of showing the world that we were the superior power. And ultimately it worked for a time. So to get back to the point, this all kind of culminated in 1968 when the CIA said, hey guys, it looks like the Soviets have this huge rocket. They've got some other hardware that we think can loop the moon before we can get a landing there. We got to do something. So they made the very daring choice to send Apollo 8 out to not just fly around the moon, but to orbit the moon and come back. And that was extremely risky, much more so than we knew at the time. But that was really, I think, the moment I got galvanized when you're hearing excerpts of the book of Genesis being read down to the earth on Christmas Eve from Apollo 8, I thought at the time, even as a young man, I thought this is going to be one of the most magical experiences of my life. And then, of course, that was followed shortly thereafter by the landing of Apollo 11, just six short months later. And then for the next 3 years, we had missions heading off as frequently as every 10 weeks. These incredible missions of exploration and discovery to increasingly challenging and dangerous parts of the moon. They were all around the equator, but you're landing near mountains and valleys and peaks and so forth. And it was just an amazing thing to see. And at that point, we had 3 television networks and a handful of radio networks, and that was it. So you couldn't jump on the internet and see whatever you wanted to see on YouTube or somewhere else. You were at the mercy of these networks. And I remember how appalled I was by the middle of the Apollo 14 moonwalk. The stuff was being televised live from the lunar surface. And once the networks realized we didn't have another Apollo 13 emergency on our hands, they got about halfway through that moonwalk and they cut away to reruns and they cut away to soap operas. And that's how fickle the American public was, and sometimes still is when it comes to this stuff. But I stayed riveted to the tube through the end of the Apollo program. And then, of course, there was Skylab, and then the shuttle began in 1981. So I grew up with this and become increasingly enamored of it. And I'll just add, the robotic program was also really picking up speed in the late 60s. We had reconnoitered Mars with orbiters. The Vikings landed on the Martian surface in 1976, and I managed to sneak into Caltech to see the live feed from JPL just up the street, which was, in a way, even more powerful than the lunar landing with Apollo 11, because you're seeing finally this first color photograph from the surface of another planet by this robot that, by all odds, should probably not have succeeded. So this was NASA really pushing the limits of what you could do with what was admittedly 1960s aerospace engineering. So it's just an amazing time, and I never looked back. So I intended to be a scientist. I studied astronomy for a couple of years at UCLA. Ultimately realized I was going to either be just adequate at that, or maybe I could be a special kind of storyteller, and that's what got me off in the direction I'm in today.
Well, good for you, because I wanted to be a rock star, and that didn't work out. So it's good to have those goals and actually achieve some level of success in what you're interested in. So do you think really that was it? You kind of touched on something there. Do you think that it was really just kind of the disinterest in the world at that point by 1972 that what we did not go back, or why we haven't gone back to the moon yet? Why do you think it is, with the current level we have in technology, everything is smaller, lighter, faster, less expensive. There are obvious, to me at least, there are obvious material benefits of the moon. From everything I've read, the moon composition is significantly different than the Earth. So there are, potentially resources there that we could use. Why do you think we haven't made that a priority to go back?
There's a couple of reasons. A lot of this came to an end because the Nixon administration came into office, and he was not in love with the idea of continuing John Kennedy's lunar program, and which later became, to a very real extent, Lyndon Johnson's program. I mean, Lyndon Johnson was really the person who pushed that through while trying to balance the demands of the Vietnam War. And Jim Webb, who was the head of NASA, was a bare-knuckled political fighter, which is what you really need in a NASA administrator. And I don't think we've had that since. We kind of have with Jim Bridenstine now, but it's been a long time in between. So because of that, you start losing the support of Congress. And that was happening even in the 60s during Apollo. There are a lot of people who wanted to stop spending money on this. And I've long thought, and there are a couple of good academic studies that suggest that had it not been, sadly, the assassination of President Kennedy, which made this thing an untouchable Democratic hot potato, that that program may well have not made it, or certainly not by the end of the 60s. It just wouldn't have been a priority. So we had accomplished a lot of goals. Apollo, as you probably know, was supposed to fly through Apollo 20 at a minimum, but Nixon canceled the last 3 missions, even as Apollo 11 was happening, and that was that. There was always an idea that we'd go back, but it was never formalized in such a way where you could nail down the funding. And there's been 3 or 4 attempts where presidents since then, including famously George H.W. Bush and George W. Bush, who stepped up to the podium and said, we're going back to the moon. We've got a new program. Here's what's going to happen. but they've just never been able to galvanize the public support or the congressional support to get the money. So, for instance, George W. Bush's program, which was called Constellation, was canceled when Obama came into office, and he commissioned a very well-funded and reasonable study to look at it, and they said, you don't have the money and you don't have the institutional knowledge to pull this off. So Constellation was canceled, but oddly, it soldiered on. The Space Launch System, which is the mega rocket that NASA is trying to build with Boeing and is way behind schedule and way over budget, is the remainder of the Constellation program along with the Orion capsule. So for 10 years, it really had very little to do and nowhere to go. And then the Trump administration comes into office and says, okay, we're going back to the moon with Artemis by 2024, which kind of rattled everybody because those of us who study and follow this and write about it, and also the Europeans who are on the hook to be our partners, were kind of blindsided by this. But ultimately, at least it's a commitment to go back. For whatever reasons, political they may be, it's a commitment to go back within a very short period of years. It's been harder than anybody thought. It's still a problem, still NASA getting full funding for it, but they've gotten more money than they've had for, well, at this point, in terms of the percentage of the federal budget, it's probably more than they've had since the 1960s. Not by much, but excuse me, it's more money than they've had for decades in terms of percentage. In the 1960s, it was up to almost 5% of the federal budget. Since then, it's been hovering around 0.5%. Now it's a little more than that. It's still barely enough. And what we're finding is we're trying to redesign and rebuild the Saturn V class rocket. That's proved more difficult than anybody thought. Part of that's Boeing, just because of the way they do business and have been doing business on this project. And part of it's just that it's still really hard to make big rockets. There's basic physics there. And even though we've come a long way technologically, it's still a big problem to overcome. However, as you pointed out in the introduction, in the middle of this, here come Jeff Bezos and Elon Musk. So they founded their companies about the same time. SpaceX started in 2002. Blue Origin, which is Bezos's company, started in 2000. Since that time, SpaceX has designed and flown the Falcon 9 rocket and the Falcon Heavy, which have revolutionized launch capabilities. I mean, we're talking about capturing half the world's market in a handful of years. And Blue Origin has been moving more slowly and quietly, but they have designed the first major new large rocket engine since if you talk about going back to basics, since the F-1 engines for the Saturn V in the 60s. So they're making great strides on the investment of these billionaires who remember the Apollo program or have learned about it and were enraptured by it and said, okay, if NASA's not going to do that, and if the Russians aren't going to do it because they're very capable in space one time, I'm going to do it myself. And now they're in partnership with the government. It's a continuous struggle, but those guys see profit there. And you touched on the idea of the moon as a resource. Of course, we want to go back and explore and discover, but we also have this new challenge of other powers, primarily China, realizing, hey, there's water on the poles. When you've got water in space, you've got the capability to go anywhere and do just about anything. The moon also has glass and metal and all kinds of other resources. But the big one is water, because you can make rocket fuel from water, you can make oxygen from water that you can breathe, and of course you can drink it. And that costs tens of thousands of dollars per gallon to launch because water's heavy. So if you've got a fuel depot up there sitting on the moon that just needs to be processed and refined, the solar system is your backyard now. You can do whatever you want. So this is this new intensive focus on the moon. Now, recently there was a bill that was authored in the House, H.R. 5666, which pushed back on Trump's NASA plan and what NASA wants to do, and said, well, we're going to do this more like Apollo. We're going to work with the traditional aerospace contractors, and NASA will own the hardware instead of these private companies. And there's a big problem with that, and there's a bunch of big problems. One of them is, by NASA's own internal studies, much less anybody else's, they have said that a company like SpaceX can do the things it's doing for between a half and a tenth the cost it is for NASA to work in traditional terms with an old school aerospace contractor. So it just doesn't make a lot of sense, and one smells the possibility of some influence there from some of the major old school aerospace companies. But one way or the other, there's a fight going on over that right now. But as you pointed out, there's a lot of good reasons to go back and a lot of things to explore and discover and money to be made.
Yeah.
And we'll talk a little bit more about that later, but that's the key here, I think.
Yeah, that is always been a question for me, is why is there this nationalistic view of everything? Why? It seems like to me like your country, your national boundaries end outside the atmosphere. At that point, once we're outside of Earth's atmosphere, we are all brothers and sisters among the stars at that point. Why can't we work together on these issues? To me, since the rewards would benefit humankind in total. It wouldn't just be why are we making claims to something? I've also seen in terms of mining asteroids or mining operations, China, we'd mentioned that China trying to be the first to get to these asteroids that are just rich in gold and different precious metals. Why does there have to be a claim to that? Why isn't that for the benefit of humankind? Is that altruistic of me? Is that
there's a conversation to be had about human nature there. I mean,
Yeah.
I work with Buzz Aldrin quite a bit. He's written forwards for my books, and we've worked on projects together over the years. And he's very much in your camp. We're in this together.
Right.
We can do it better united than we can separately. So let's stop duplicating each other's efforts and move ahead. Of course, the problem that you have is we are in this commercial war, I'd say, with China. There's a lot of concern about intellectual property, which is where the ITAR rules and so forth come in, which say you can't have technology transfer, information transfer. NASA would love to work with more international partners, and China's the powerhouse, both in terms of technical capability and money, but they are forestalled by the law from doing that. So we've got these parallel efforts going. As far as who claims what up there, this has been a long-standing problem. There is the Outer Space Treaty of 1967, which says space is for everybody. You can't claim things. You can't have weapons of mass destruction up there, and so on. Then there was a later attempt to do a moon treaty, which would have treated the moon in a similar way. And this is all kind of based on the old Antarctic Treaty, which said, okay, this is for everybody. You can't claim territory there.
Right.
And that's been very successful. We have a number of nations with major bases down there doing research, and that's what we've been doing ever since the 50s, and it's worked very well. The problem with space is you're beginning to see potential profits and even military advantages to operating in orbit, and especially on the moon, and potentially with asteroids. So there's this bigger concern about private property, and a large part of that is focused on people being able to make money out there. Because if you're a private company, you want to be able to attract investment, and to attract investment, you have to have a certain amount of ownership. So I think the way it's been best put was by a gentleman named Rick Tumlinson, who's been a long-time voice in the new space field, who says, I don't need to own the ocean. I just need to be able to own the fish I pull out of it. So if you're sitting on the lunar South Pole, where this water, we think these big water reserves are, do you necessarily need to claim territory? No, but you want to be able to make a stake on that particular chunk of real estate so you can pull out water ice and have machinery there, probably robotic up at the beginning. Eventually it'll be crewed with people to be able to pull up these resources and utilize them to move further out and do more things. But there's a lot of concern about militarism and what'll happen if a foreign power gets established up there that we feel has some hostility towards us. And now the Space Force enters into the equation. What are they going to do? What's their purpose there? Are they there to wage orbital warfare? Are they there to just protect our satellite assets? Well, you can't really do that because a satellite passes over the same part of the Earth or sits in one part of the sky all the time. So they're kind of impossible to defend. So now you get a bigger conversation about mobile forces and things that are impossible to target and so forth. And that's kind of beyond the scope of this conversation. But it's a part of being able to protect these lanes of transport and the source of your raw materials. So that's where this jealousy about real estate, which ultimately becomes a very nationalistic discussion, comes from. And there's increasingly strident voices on both sides of the equation to say, look, we need to go on our own and make sure that we get our piece of the pie. And there are a number of other countries that are also trying to enter this discussion, but they don't have space capabilities. So at least not in terms of manned space flight, human space flight. So the European Space Agency, the Russians are sort of straddling that divide because they have human spaceflight capability, but they don't have deep space capability at this point. The Chinese are very close to having both. India wants a piece of the action. And then a number of other countries, including Israel, say, well, we want to be part of this great adventure too. So we're trying to come up, and I say we, the U.S. government and various private organizations like the National Space Society, who I work with, are trying to come up with some reasonable approaches to this, but it involves a lot of study and a ton of negotiation and introducing bills on the floor of the Congress and the Senate and so forth. And you have to hammer these things out. There was a little progress made under the Obama administration by kind of unilaterally legalizing staking claims to resources, but that's not yet been accepted across international boundaries, and so that's something that's still very much in flux.
It seems to me like just because a company or a country does not have space capability doesn't mean they can't be involved. It's almost to me like I have a pizza oven and you want some pizza. You can still bring me some dough for crust, and I can still make the pizza. It seems like there could be some other resources or other materials that can be provided by, some of these countries who can't actually make it there themselves. And, they kind of provide that as, here it is, this is our contribution. Now we're part of this with you. And it seems like there could definitely be done at some point. Maybe this is me just, again, being idealistic. At some point, I think when we start reaching past our planet, we kind of have to start thinking of as kind of we are one together. We're really outside of that really tiny fishbowl now. We're in this enormous, pond, and there are much bigger fish there that we need to kind of look out for each other. But, I don't know. Maybe Well,
I think you're right, and ideally this is how it would go. So we've seen with the International Space Station, I mean, there's a reason it's the International Space Station. There's a consortium of nations working there. China, sadly, was excluded from that for the reasons I've already gone into. But Japan is involved, the European Space Agency is involved, a bunch of other countries are involved, and everybody's contributed something. The bulk of it was paid for by the U.S., over half. And then we got in this weird position without the space shuttle once it was finished, and that was the reason the shuttle flew out through 2011, was to finish the space station. And then we've been buying rides from the Russians to get up there ever since, which made a lot of people very uncomfortable. This year, actually in a matter of months, if all things go well, SpaceX will start carrying American astronauts up there, and we're back in the game. But ultimately, it's been a real model for international cooperation overhead. And even during the difficulties with the incursion into Ukraine by Russia, things were still going very well on the space station side. NASA and the Russians were still being civil to each other. Everybody was getting along up there. The two mission controls down on Earth in Russia and the United States were getting along. And although there was a lot of tension between the governments, space was kind of staying above and beyond all that, not to coin a pun. And things were going very well. So we've shown we can do it. The question is, can we kind of memorialize this in such a way moving ahead that we can assure that we're not going to have conflicts in the future? And that would be ideal. It just seems to be a little contrary to basic human nature, unfortunately, and the desire to try and corner these resources and have military advantage. And that's a big part of the conversation now, of course, as I touched on earlier with Space Force. You've got a very capable military orbital interdiction ability by the Russians and the Chinese, who can affect and possibly take down American satellites. And a lot of people don't realize how important those are. It's not just for military advantage. They control banking transactions. They control the energy grid. They control agriculture. A lot of agricultural monitoring is done from orbit. Everything we know about climate change in the bulk sense comes from orbit. So these satellites become critically important parts of national security. And the fact that the bad guys, quote unquote, can actually blind or take down that hardware has got a lot of people very upset, which is why Space Force finally got funded, because the idea is, of course, that they can help protect those resources. And, the other people involved in this discussion, China and Russia in particular, aren't laying back and waiting either. They're both developing very quickly abilities to go up and inspect and possibly disable satellites and other capabilities in orbit. So it becomes a very tense situation quickly if you're not careful. But ultimately, it would be best if we could work together and get these interests united. In our current situation with the COVID-19 virus, it's kind of interesting to watch. I say interesting, that's kind of cold-hearted. but it's gratifying actually to watch what international cooperation is going on. So China,
Right.
for instance, sending teams of doctors all over the world to help other people because they think they've got a handle on how to work it out. We're sort of still scrambling around trying to figure out what we're going to do, as is Italy and the rest of Europe and other countries. So, between what we've seen with the International Space Station and what we're seeing now with this emergency that we're currently in, can we see a better path forward for working together? I hope so. And that's, as I said earlier, where my discussions with Buzz have been so fascinating to me, Buzz Aldrin, because he has been an advocate of this since he got back from the moon. So of all the Apollo astronauts, who were a great bunch of people, I know a bunch of them, they're wonderful guys, but I think of that crew, of that cadre from the space race era, he was the one person that never stopped pushing this vision forward. We've got to go above, we've got to go beyond, we've got to reach for Mars, return to the moon if necessary, but we've got to do it together, and I really laud his efforts in that.
So let's talk just about exploration for a few questions here. So I heard, I believe his name is Alan Pettit, a NASA scientist, was talking about how they would love to go back to the moon again, but they don't have the technology. And I think maybe he was misquoted a little bit or kind of out of context a little bit. What does that necessarily mean, that we no longer have the technology to do a deep space run, outside of the low Earth orbit, when we had that in 1969, early 1970s?
So there's a couple of ways to look at that. One is a lot of institutional knowledge was lost over the 50 years in between what will soon be coming up as our 50th anniversary from the last moon flight and now. So a lot of those engineers aged out and retired. The blueprints, of course, were kept, but not always findable. That's a lot of data to hang on to. So, for instance, a few years ago, there was some thought about recycling the Saturn V's F1 engine, the first stage engines, back into the inventory because it was the largest single-chamber rocket engine ever made. It had 1,500,000 pounds of thrust, or about triple the biggest ones we're using now. So they went to look at, can we simplify that design and start remanufacturing them? As it turned out, they actually had to send engineers to the museums to take apart some parts of that engine and measure them and reconstruct them using modern techniques, 3D printing and so forth. And that was successful, but it does show you that there's been some ability lost. Now, on top of that, you've got, as you pointed out at the beginning, a lot of advances since then. Electronics are smaller. Digitization is much more a part of the conversation than it was then. We no longer have analog electronics to worry about. They're more energy efficient.
Right.
They take smaller power supplies. I mean, there's 100 things or more that make this, in theory, easier to do than before. But you still have these basic challenges. Getting off of Earth, going up is a lot harder than going sideways. So you've got to have big, heavy lift rockets. You've got to have life support systems. We haven't, other than the space station, we haven't really worked on that in terms of making the compacted, transportable out to the moon or beyond for a very long time. And of all things, spacesuits. We haven't had a spacesuit that had to do anything other than hover in space next to the space station for half a century. And they've got to be sort of redesigned and figured out from the ground up. We've got some basic knowledge there, but we need to redesign them, and that's a big challenge facing the Artemis lunar program. So there's a whole bunch of things that have to be figured out and redone. It's not impossible. It's not magic. It just takes money, and it takes the desire to do it. And when you're looking at Apollo, which, as I said, was up to 5% almost of the federal budget, they had a lot of money to work with, and they had almost 500,000 people attacking that problem. Now we've got much smaller budgets. We've got this interesting mix of private industry and government moving ahead, which we didn't have then. And it has been demonstrated again and again that can be a really effective combination. But private industry isn't going to put all that money in on their own because there's no assured return. It's a suspected return. It's an expected return. We think it's going to be the first $1 trillion economy in a single area by, say, 2035 or so, according to some of the financial analysts. But you've got to have some investment there from government to make it happen. So a lot of people liken this, and I recently wrote an op-ed for Space News with a gentleman named Greg Autry where we talked about this. It's a little bit like airmail was back in the beginning of the 20th century when government stepped in and said, okay, these barnstormers, these private operators are driving us nuts. We're going to set up a system for this. We're going to regulate it. We're going to put money and resources into it, and then we're going to step back and let commercial air transport for both mail and passengers work on its own. And it worked brilliantly. So if you look at that model, which is where NASA's kind of headed now with their cooperation, if they're allowed to do it, between a federal agency putting money in and seeding this, and then stepping back and letting private industry do the heavy lifting and let NASA do what it does best, which is exploration and pushing those boundaries. Now you've really got some magic there. And if you can add the third element of the international sector doing what they do best, because everybody's got their own set of capabilities and intellectual brilliance, now that's where the magic happens in this new Space 2.0 era. But we're not quite there yet.
Do there have to be significant changes or differences? Because I know you had mentioned spacesuits, and we have spacesuits. Do there have to be modifications or changes to a spacesuit to go out past radiation belts and be out into deep space versus to be in low Earth orbit when you're really kind of protected, right? We have those Van Allen radiation belts which protect us in low Earth orbit. Does there have to be some kind of additional protection to the spacesuit and the ship itself?
The spacecraft itself desperately needs protection because once you talk about long-term journeys like many months to Mars, now you've got a crew that's going to be saturated by radiation.
Right.
So it's not the suits really, it's the spacecraft itself. So some of the ways they're looking at is either putting a large volume of water or fuels around the crew compartment, especially if there's a solar flare, because there's radiation from both the sun and from outside the solar system. You can't abate all of it, but you can at least get it down to a manageable level if you can put enough shielding around the crew. You don't want to use lead because it's too heavy, obviously. But if you can get a big volume of water, or as some people have suggested, even if you go to an asteroid or the moon and get a bunch of rubble, you can use that if it's utilized properly. So radiation's one problem. When you're talking about spacesuits, the big problem is when you land on the moon or Mars. So in both cases, these are places that haven't had weather, in the moon's case, ever. In Mars' case, for millions of years, other than wind, there's been no rain. So you've got this very fine grit that's very sharp and highly erosive. So for instance, if you're on the moon and you've got a base there and you're going in and out of a moon base with spacesuits, you're dragging this dust in. In both cases, for different reasons, on the moon and Mars, this dust is hostile to humans because you don't want to breathe it. In the moon's case, we're pretty sure you can get cancer from it. It's a little bit like breathing asbestos. On Mars, it's actually laced with perchlorate, so it's highly reactive and would cause mucous membranes to be inflamed and other deleterious effects of the human body. So dust is a big problem because it's tough on people and machines. The seals on the suits will fail. And it's so fine. And in the moon's case, you get actually electrostatic adhesion. It'll jump up and adhere to your suit. So if you look back at Apollo photos, by the time those guys have been out on the lunar surface a couple of hours, they were filthy. And no matter what they did, this stuff was ground into and sticking to their suits. And the lunar module soon looked like a sandbox with all this dust and grit in it. So that's really the big challenge, besides just making sure these things will operate over a long period of time. When you look back at Apollo, it's amazing. I mean, those suits were a one-use thing, right? They went out for 2 or 3 moonwalks, and then they went back up to orbit and came home, and that was that. But the fact that those backpacks, first time we ever did it, those life support backpacks could work up to 18, 20 hours to keep these guys alive. And it's not just air. They're circulating water through their spacesuits because one side's about 250 degrees above zero. The other side's 250 or more below, just depending where the sun's touching it, striking it. So the fact that they pulled that off then is just remarkable. And it's astounding how hard it is to do it again, because, again, we haven't really looked into that kind of technology exactly like that for a very long time. We have something like that for the space station, but it's not quite up to the specs that it was for Apollo. So those are all considerations when it comes to spacesuits.
Well, I was always really perplexed and frightened watching the video footage of them walking around. Because to your point, you're saying that the dust is incredibly abrasive and sharp, and the amount of times that they fell on the moon's surface. And, to me, I could not imagine being alive during that time frame because I was born in 73. So I was not alive in that time frame. I can't imagine watching that on television, seeing somebody just basically trip and fall, which they did, it seemed like hundreds of times, rupture their suit and die on national television.
Right.
That is the stakes that we're talking about. And people got disinterested with that, which is amazing to me. Well,
Those suits were very tough. They had, I think, up to a dozen layers in them
mm-hmm.
of beta cloth, which is kind of a fiberglass material, and rubberized bladders that would, of course, keep the air inside and so forth. So they were very tough. And most of those falls, if you watch, occasionally they would trip over something. But most of those tumbles that you see on the old videos are when they were trying to drill core samples. They had such a hard time getting the drill core tubes out that they had to yank and pull and tug and use jack handles and everything else. And Apollo suits were not very flexible, so if you started to go over, you were going to go all the way over. And of course, at Mission Control, they were holding their breath because there was always that concern that if they landed on their backpack, it would stop working.
Right.
Or like you said, they'd tear their suit or what have you. But, lunar gravity is only about 16% of Earth, so if you do go down, it's much less of an impact than it would be here because you're just not hitting it with the same amount of force. So it wasn't quite as dangerous as it looked, but it certainly wasn't ideal. And those guys, of course, if you listen to the downlinks, were just laughing it off. They were having a great time up there, and they weren't particularly worried about it. But it is something that certainly deserves a great deal of caution.
So when you're talking about the radiation, you're talking about long-term exposure. What time frame are we talking about there? Because those guys were out past those fields for, well, how long? Maybe a week, max? How long are we
12
talking
days,
about?
14 days. Yeah, maximum of a little under 2 weeks. If you're heading off to Mars, you're talking about a 5-month transit.
5 months. Okay.
However long you're going to spend on the surface. It can either, depending on which mission profile you're looking at, it's either a month or many, many months. And then coming back. And the problem on Mars, of course, is, and the moon, you don't have the magnetic fields and the atmosphere density that you do on Earth. So in both cases, you're also getting saturated while you're on the surface. So that's why you see a lot of work being done on looking at lava tubes and pits, these volcanic pits that go down under the surface so that you can be down underneath a bunch of rock, which will protect you very handily. And it's right there. Mother Nature's put it there. All you need to do is go down there and build your habitat inside those areas. It's not much of a view. You're just looking at a cave. But then you can do your sorties outside and you're in good shape. Initially, it'll probably be on the surface. They may take up cranes and diggers to be able to put what they call regolith, which is a surface material of either the moon or Mars, just dirt and rocks. You can put those over the shelter, and if you put enough of it, something in the order of 8 to 12 feet, you can shelter from the radiation. But it's a lot of work. It's a lot of mechanical effort. It's a lot of man hours, and that will be something we'll have to deal with because there's just no way around it. There has been some other work. I wrote about a project they were doing up at Jet Propulsion Laboratory in Pasadena, which was a new kind of very lightweight, almost like big, thick sheets of styrofoam, but with a bunch of chemicals in it, that you could have on a spacecraft that would, once it got out of the nose cone of the rocket, these things would unfold and cover the spacecraft, and they're 2 or 3 inches thick. It ends up looking like it's encased in, like I said, these big blocks of modular styrofoam or something. But that's one approach. There are other approaches that include pharmaceuticals that may help mitigate some of the damage from radiation. And then there's just the idea that if you talk to astronauts, most of them know what they signed up for, and they're quite willing to do this. Did you take a bigger risk? You're going to have a higher possibility of having cancer as you get older, and you're going to have possible reproductive harm if these astronauts are younger and they're still in childbearing years. But I have yet to meet one that hasn't said, I knew that taking this job, and for this effort, for the betterment of human society and for my own personal gratification, I'm willing to take those risks. Just let me go. But NASA has its standards, and the Russians have their standards, the Chinese have their standards. So it's something that is an ongoing effort to try and figure out how to deal with that.
So what is the ultimate goal of the journey to Mars? Is it strictly colonization, or are there potential resources there as well that we're looking for mining?
That's an interesting question, and I was writing a book called Space 2.0 starting in 2016, 2017. I was interviewing Gwynne Shotwell, who's the president of SpaceX. She works directly under Elon Musk. And I said, how do you close that business case? And she said, it's easy. You get enough people to go for enough money, and it works. We just have to get our launch costs way down. That's possibly a little simplistic, but that's their point of view. If you talk to different people, you get different answers. So in Musk's case, his vision of Mars, besides it's just something that he always wanted to do and still wants to do, is that it's kind of the backup drive for Earth. Something cataclysmic happens on Earth, got a colony on Mars, and there are people there, and that's okay. Jeff Bezos' vision is a little different. He wants colonies up in Earth orbit and beyond in what's called cislunar space between the Earth and the Moon, at these stable points called Lagrange points, where you can have a smaller orbit where it stays effectively in one spot in space due to the gravitational balances. And he wants colonies there for somewhat the same reasons. He goes on to say that he wants to get heavy industry off of Earth and let the planet recover from the Industrial Revolution and beyond, and also have people out there living separate lives. And then you get into larger discussions, depending on who you're talking to, about, utopian societies and different groups can do their own thing and so forth. But ultimately, it kind of comes down to, as you're alluding to, what's the practical use of going someplace like Mars? The Moon is easy,
right?
Because we've got resources up there we can use to go above and beyond. It's much easier to get those resources out of the lunar gravity well. So that's a place where we know we got a gas station sitting right there. We've got a foundry sitting right up there. That's a couple days away. It's relatively easy in comparison to anything else, and that's a given. When you talk about Mars, it's also got a ton of water. There's enough water on Mars, we think, to cover the whole planet in an ocean about 30 feet deep. And a lot of it's salty and alkaline. A lot of it's not. Some of it's fresh. So there's a ton of water resources there. There's also metals, of course, and the same kind of things you find in any planet. But there's that bigger discussion that's a little more philosophical in nature of going above and beyond in the next horizon, the final frontier, and all that. A lot of people will say, well, we still haven't really explored the seas, and that's true, but we do have a pretty good idea of what, on average, the seafloor is like, what's down there,
right?
How it can be used or not used. We don't know much about Mars yet. What we know is what the robots have told us, and while they've been very capable and done amazing things, exclusively American on the surface, there's still a lot we're going to find just by sending a geologist or two up there. And that's where sample return becomes such a fascinating part of the conversation. If we can get some rocks back, which NASA's working very hard to do, possibly in the next 6 to 7 years, now you can begin to see what's really going on. You're just looking at a tiny bit of the surface. You're not getting down into the crust. But at least you finally have a way of really knowing what those rocks are all about and what the elements are that are there. And that will tell us a lot.
So on the Moon, when talking about basically the Citgo station, the filling station, what is the benefit of? I've read that they were talking about a couple of different approaches, either a lunar gateway in orbit outside the Moon, or just strictly landing directly on the Moon, having a base there, a landing pad there, and allowing you to to kind of do your work there. What are the benefits either way? And in your opinion, would it be better to have that lunar gateway and take the time that it takes to build that first? Or, because that's the big issue to me, is it's going to take a long time to build that gateway versus going directly to the Moon, landing there, and building your infrastructure there once you land. What are your thoughts on that?
That's a great question. And if you want to get a food fight started, you get a bunch of space advocates and politicians and engineers in a room, and you say, gateway or direct landing?
Yes.
And stand back and watch the flames fly. So gateway is an interesting concept. It's a station, smaller version of the space station. It would be in orbit around the Moon in what's called a rectilinear halo orbit. So it's kind of side on to us. And it has some advantages and some disadvantages. Some of the advantages are it is good for some of the aerospace contractors because it's something that they want to build. Mm-hmm. We know we can build space station modules or repurpose existing ones if we disassemble the space station potentially, although they probably won't do that. We can get international partners who are very good, like the Russians, at building power and propulsion elements and so forth, involved if we choose to, although at the rate we're going, it'll probably be an American effort. So you have this way station there, which would be crewed part of the time. Now the question becomes, do you really need that there, or can you go directly back and forth from the surface? And the answer is yes and no. If you approach the program in a certain way and bring in certain players like Blue Origin, Jeff Bezos has been working on his own lunar lander for years now, very convenient for us, if that choice is made. Now you've got the potential for a direct landing if you have big enough rockets. If you have smaller rockets, the gateway becomes essential because it's difficult to get directly down to the surface and back. And now enters the conversation of the Space Launch System, this big heavy lift rocket that's expendable and not very economically sustainable compared to what SpaceX is doing, for instance, with recoverable rockets. Do you want to use a bunch of smaller commercially built rockets to try and assemble things in orbit and have this sort of built-up train approach? We'll bring up this piece and this piece and this piece and hitch them together and head off to the moon, do what we want to do. Or do you want to have a way station there where you park and go down and back and forth from there? And there is no good answer. You'll get opinions from both sides. It just kind of depends on what you want to do. Part of the rationale behind the Lunar Gateway was because the SLS rocket, the big NASA government rocket, as currently envisioned, the smaller upper stage, there were two designs, one for a smaller one and one for a larger, more powerful one. At this point, they've only approved and started developing the smaller one. And because of that, you don't have enough power with a single launch to go all the way to the moon's surface and back, at least not with any capability. So if you want to do these big kind of expeditionary single rocket missions like we did in the 60s, that's not going to work without some heavy modification, a lot more investment. But if you're willing to do something more modular in approach, where you have perhaps, and I'm kind of going out a little further here, but if you have refueling depots in Earth orbit and you have refueling capability on the moon, you have dedicated tugs that move back and forth and dedicated landers, so it's not all being launched on one rocket like we did in the 60s. Now you've got a much more modular and expandable system that we can sustain over time and actually have a meaningful long-term presence there on the moon to develop these resources and to develop biosciences and to learn more about living in a radiation-saturated environment and far from Earth and so forth. But it's a lot of investment and it's a lot of political wrangling, frankly, to figure out where the balance is between government and private industry in the international sector. And that's why you're seeing this news morph and move, and NASA's direction keeps getting shifted one way or the other. It's primarily about politics and money spent here on Earth. We don't ever fly money into space. We don't shovel gold doubloons into a space capsule. It's all spent here on, in our case, mostly on American companies and American workers, which is a good thing. It's the only thing other than the armaments industry that's exclusively American in nature, is our space program. But of course, you've got all kinds of constituencies and regional influences and so forth, and this is why you see so much wrangling going on.
Is the presence on the moon needed first before we can go to Mars, or is it should there be things in place? You know what I mean? So the first step is we get to the moon and we build that refueling station, or we take the information we need there, so then we can hit that as a kind of a starting point, and then from there we go to Mars. Is that necessary to do it that way, or is it the better idea to do it that way? What do you think?
This is another one of those food fight questions. So you'll get organizations and people and politicians and engineers and scientists that will tell you with equal conviction and passion that both those things are true. So the Mars First bunch, or Mars Direct bunch, whatever you want to call them, says, let's not muck around with the moon. We've been there. We've seen it. We know what it's all about. Let's go straight to Mars. We can do it. The problem is it's much, much more expensive and difficult to do. We do have experience in low Earth orbit for up to a year at a time with people, but we don't have experience transiting this vast gulf, this interplanetary gulf between the Earth and Mars, where you can be months away from Earth return and you have an emergency. Imagine if you're on a spacecraft and some kind of nasty virus suddenly gets hold of people like we're experiencing now, you've got a mission failure.
Yeah,
and we don't want that. So if you could do some of these incremental steps at the moon, and yes, it takes away from money that would go to human flight to Mars. Personally, I'm not convinced we need to move that quickly on Mars. It's good to have people going up there and doing research and pioneering that frontier. But for my money, I'd rather see us learn our lessons at the moon, both in lunar orbit and on the surface, really work out life support over the long term, work out how to fly small nuclear reactors for power, because it's unlikely you're going to get it all from solar panels initially, especially on the spacecraft itself, work out radiation abatement and all these difficult things. Because one thing we've discovered since the space age, in the 1950s, Wernher von Braun had put together a very wonderfully detailed plan of how to send an armada of 10 spaceships out to Mars, land there, explore the surface and come back, and it was going to involve a transit from landing the first ship at the Martian North Pole and overlanding down to the equator and building a landing pad for other spacecraft and so forth. It was very ambitious. A lot of problems there, including that Mars's atmosphere is a lot thinner than we thought, so the gliders would have crashed and so forth. But the bigger problem is the solar system just turned out to be a much more hostile place than we thought, and we really have come to understand space just hates people.
Yeah.
We go at our own peril. It takes a tremendous amount of technology and effort and money and mass to make it work. So I think the more increments you can have, especially again if you can use these lunar resources to further the effort, the better off you are. It is worth saying, and the Mars First people would say this, there's plenty of water there to make rocket fuel and breathable oxygen as well. So you do have resources there. You just have to go a lot further to get them. And you're going to have to send robots to do it first so they can prepare all this stuff for humans to get there and be able to come home affordably. So you can go either approach, but if you're asking my opinion, I say let's do the moon first.
Yeah.
Really build up a capability there. And maybe while we're doing that, we can learn how to really unify international efforts. So when we take that big step off to go to the red planet, that we're doing it in partnership with China and Russia and other people that are willing to contribute to this and spread out the cost of the challenges.
Yeah, I think that I agree with you there. That I think that the Mars isn't going anywhere, at least not in the short term. I mean, it's going to be there, but what we could obtain from the moon, landing on the moon, mining the moon, building those resources on the moon, it is going to have some type of financial bring back. We're going to bring some finances back from the things that we can get from there. So just to say, oh, it costs a lot of money to go there, let's just go here instead. Well, you're going to get some of that back, especially in terms of, like you said, the different knowledges and things like that. It's much easier to get back and forth. Humans are weird, though, because we're the only thing I can think of that you could, there's no other animal that I'll say, if you go right there, you're going to die 100%. And most animals won't do it. Humans will figure out a way to do it. Or like, well, we're going to go there anyway. We'll just figure something to wrap ourselves in so we can survive.
Right. We have that kind of, like,
exactly.
You're going to challenge me on that? I'll show you. And that's part of the wonder of being human, is that we have this drive to do what seems impossible. And just stepping back for a moment, when I was growing up and President Kennedy said, we're going to the moon, there were a lot of people that said, what?
Yeah.
That's going to be extremely difficult. And it was. When President Kennedy made that announcement, we had a total of 15 minutes suborbital flight time with the Mercury program. Alan Shepard, one flight. It was audacious. And people at NASA looked at each other and kind of wide-eyed said, yay, I think. How the hell are we going to do this? And it was a magnificent effort that was overcome by the application of a lot of money, a lot of brain power, and brute force. Hopefully we know better now to do a slightly more refined approach with what we've learned. Can really do this in an intelligent, sustainable way. And I think that's the key, sustainability. If you can get infrastructure built up in low Earth orbit at the moon, get regular tugs, whether they're robotic or crewed, going back and forth between the Earth and the moon, transiting this material back and forth, crews, supplies, that kind of thing, and repositioning, taking some of those lunar resources, fuel, for instance, that we refine there, bring it back and park it in low Earth orbit. So you can retank once you get off the ground and up into the Earth orbit. You can refill the tanks there, as SpaceX, among others, is planning to do, and then go out and beyond. Now you're not having to fly these enormous rockets up every time. You've got a depot there, and you've really got the beginnings of infrastructure, like when we built interstate highways in the 1950s.
In terms of goals, are there any goals right now beyond the solar system? I know, we're talking about colonizing Mars, but I've also seen a lot of movies where they mention Europa or Io or other, satellites that they're saying that this could also potentially support human life. Are there anything outside eventually that we're saying, okay, we want to point in that direction when we go exploring?
There's a really active discussion there, and a lot of it's about, it's a little more abstract than what we've been talking about so far, and it involves planetary protection. So those moons, Enceladus and Europa in particular, are Category 5 bodies, so they need the ultimate in planetary protection. We don't want to pollute them with germs because we're concerned that there's indigenous life there, microbial or otherwise. And on the surface is one thing. I mean, that's why the Cassini probe, which had labored out in orbit around the various bodies around Saturn for a decade or two, that's why it was ultimately deorbited into Saturn, because it was the one place where it wouldn't do any harm. You're not going to hurt Saturn. It's a big hot ball of gas, no big deal. But if you leave that thing there and it loses its ability to maneuver and you crash into one of those moons that we think may have life, there's plutonium on that thing for its power generation. So you don't want that to happen. So that's how careful they are. On Mars, when you've got a rover, you're not allowed to approach an active source of water. Ice is one thing, but if you've got water, for instance, there's water that we think comes out of the sides of some of the gullies and ravines there during certain times of the day. It looks like there's water seeping out. You don't want to go touch that, because if that machine isn't completely sterilized, you may irrevocably damage indigenous life there, because now you've got two life forms, different planets making contact. You don't want that. So that's a big part of that conversation. It kind of puts Europa and Enceladus and some of the other icy moons that may have oceans below the surface off limits for a while for human beings, because we're just big bags of germs. And there's really no way to mitigate that successfully. But if you've got a machine that's sufficiently sterilized, that's something you can do. Another thing is, what do you gain by going out there? From an exploration perspective, it would be magnificent. But in terms of settlement of people out there, maybe on Titan, because Saturn's moon Titan, because it's got a pretty dense atmosphere, and we think we might be able to successfully sustain a colony there, or a settlement there, or an outpost. There's been talk about having floating outposts in the atmosphere of Venus at a certain altitude. The pressures are about right. You can't breathe it, but you can have, we think, enormous Zeppelin-type balloons that would have a large scientific station underneath it that could just sort of drift around the atmosphere. You don't want to go down the surface, because it's a nasty place down there. It's 900 degrees plus Fahrenheit and extremely high pressure. But up in the clouds, you can do things. So the terrestrial planets out to and including possibly the asteroid belt makes sense. Further out, that's kind of crossing that next big bridge. And then, of course, as you touched on, there's the idea of interstellar. And you talk about the nearest star system, which is 4 light years away, or something like 80,000 years for Voyager to get there.
Right.
You're going to have to come up with much faster ways of doing business in terms of propulsion. And actually, I'm on the board of a group called the Tau Zero Foundation, which is working on some of these problems. And we support research projects that look into advanced propulsion and the kind of energy that it will take and energy storage it will take to be able to move between star systems.
So I have two more questions, if that's okay.
Sure.
My first question is, I read a report, I don't know, last year sometime, where they were talking about how New York was doing a dry run or a practice run regarding an asteroid strike. And I said at the time to my wife, when I read this story, I said, they think something's up there, or they know something's up there, and they are socializing us now to the possibility that it may hit. And, whether or not they did or not, that's what I like to say. Sure enough, though, over the next couple of months, there were 3-4 things that were quote unquote near Earth orbits or near Earth events. Is there any type of technology currently being developed that would potentially defend Earth from these celestial bodies, these asteroids, these things that are coming through? Is that any part of what Space Force might be used for? Any way that do we use to redirect things that may be coming into our sphere?
It's part of the conversation with Space Force, but I don't think it's been embodied yet as part of their mission, but it needs to be. So this has been a conversation going on for decades. We know we live in a cosmic shooting gallery. There's large rocks out there constantly whizzing back and forth. Some are regular and repeating, some are not, some are random. But we get nervous when they come between the Earth and the Moon's orbits, because that's a close miss. And if they're large, even Chelyabinsk, the 2013 meteor entry over Russia was only about 60 feet wide, and yet it was the size of it was the power of a small nuclear weapon once it exploded. So you get into bigger rocks in the order of hundreds of feet, and it starts getting scary. You've got a city killer. So it's a very active area of concern. There wasn't much being done until 2010, when the Obama administration came into office, and his new NASA administration said, okay, because they change usually with an administration shift, said, okay, we've got to really ramp this up. So they increased the budget for trying to find what's out there and at least chart where it is and where it's going by 10 times. So we know a lot more about what the threats are. Now we have to figure out how to mitigate them. There's a mission slated for the mid-2020s called DART, the Double Asteroid Redirect mission. I haven't got the acronym right, but you know where I'm going.
Yeah.
And it's a spacecraft that was originally going to be with the European Space Agency. Now it looks like it's just a NASA thing. But basically, it's a spacecraft that's going to go out to this asteroid called Didymos. And it has a smaller body orbiting it, which we call Didymoon. Isn't that cute? And we think Didymoon is small enough that if we take a spacecraft and set it out there and slam it into it at high velocity, that it'll deflect it just enough that we can measure it via telescopes from Earth. And this will give us an idea of at least one way of altering the trajectory of smaller objects. Now, obviously, if we're talking about larger asteroids, we're going to have to figure out something else. The Russians have talked about potentially repurposing some of their extensive nuclear arsenal to send up a nuke or a series of nuclear weapons, not to blow the thing up, because you're still going to have a big mass of rock headed in the same general direction, which we don't want, but to perhaps deflect with an explosion, and the heat of that explosion cause that body to deflect. And if you get it far enough away, you only need to nudge it a degree or two to have it pass by Earth safely, as long as you've got all your math correct. They're also looking at things. Here's a weird one for you. There's been discussion of, hey, if you've got a big asteroid and you can paint one side of it white, the radiation that's emitted from that, because it's the black side absorbs more from the sun and the white reflects more, it would create a differential that would essentially propel it out of the trajectory it's on. So there's a lot of things being looked at. Even attaching rocket engines is just knocking them off course. The key is researching this, testing the technology, getting it out there, testing it on site, and just picking one and saying, okay, we figured out how to deflect this as long as we detect it early enough. Then we need to have more telescopes up in orbit to be able to detect these things and give us sufficient advance warning that we can put all this together. But you're absolutely right. It's critical to figure out, because it's not a matter of if it's going to happen, it's when. And we're kind of overdue for a big rock. Don't want to be sitting here like the dinosaurs just looking in the sky going, oops, should have thought of that.
If I'm putting my wish list together in terms of space, in terms of anything space related, number one is defense of the planet. Number one is defending the planet from this shooting gallery. Number two is then, okay, now we have our defenses in place. We are not going to be wiped out by a VW bus shaped, size rock hitting us. Now, okay, we can go to the moon. Now we can do all the getting the system, the fueling systems up and running in the moon, getting ourselves stationed appropriately and staged appropriately for going out farther. Those all seem logical. It seems kind of a logical progression. You start in and then you go out versus going out immediately because you think you've already been everywhere in. I don't know. I just think that 3 missions to the moon, or I guess more than that, 3 years worth of missions to the moon, probably wasn't enough. Yeah, there's probably a few more things there that we could find. I mean, I've lived in my house 6 years. There's probably pieces of my house that I haven't seen yet.
Right.
So I'm sure there are things we could find there. My final question to you then is, Rod, if you are putting your crystal ball out and you're looking 80 years into the future, we're unfortunately both gone probably at that time. You're looking 80 years into the future. Where will we be at with regards to space exploration, colonization by the end of this century, which is 80 years from now?
So I'm going to take 2 approaches.
Okay.
The pessimistic one is we're almost as far from the Apollo landings now as they were from the Wright brothers' first attempts at every flight. And when you look at the progress we've made in that time, we've done a ton of exploration of the solar system with robots, but in human space flight, we haven't done a lot. We built a magnificent space station. We flew the space shuttle. We flew some rockets like the Soyuz rockets, but we just haven't done enough in most people's estimation in my field. And that's a shame. So I don't want to see another 50 years go by where that doesn't happen. Fortunately, we've got a re-energized NASA. We have China ascendant, and they don't plan 3 or 4 years at a time like we do here because of presidential administration shifts. They plan a decade or more in advance, and they stick to it, and they make it happen. India, to some extent, the same way. So we've got some major international powers getting interested in this. And then finally, we've got the private sector, primarily in the U.S. at this point, very powerful, very entrepreneurial. SpaceX is a miracle in my estimation of achievement. Recently, they had a successful pressurization test of Elon's Starship, which is his big mega rocket that's going to make the Saturn V look like a skyrocket. in terms of being able to lift cargo and people, and it's reusable, and it's got tremendous capacity. He had a couple of explosions with his iterative testing, and he's a big fan of testing to destruction and then redesigning it, which is one way of doing it. It's a very smart way of doing it. He had a successful test, but after the second failure, he pulled his engineers together at midnight, because that's how Elon is, and said, "This is not acceptable. Tell me what you need." And they said, "We need twice as many people, and we need double shifts." And he said, "Done." So he doubled the workforce, literally in the course of a day or two. He had people lining up at a work fair at midnight, getting jobs, put them on the clock. They're working 2 12-hour shifts, and then they get 3 or 4 days off, depending on the week. And he is pushing these people. It's like a wartime economy, a wartime kind of effort, that sort of drive to make it happen. And that's just him. Bezos, a little more paced, a little slower, but he's putting well over $1 billion of his own money into that rocket hobby of his each year, which he can still do it for another 100 years, which is pretty cool with the amount of money he's got. So these guys are showing tremendous drive, and if we can get that integrated with government, we've really got something going here. So I'm getting a little off track, but if I look out 50, 80 years under those circumstances, I see tremendous infrastructure in low Earth orbit with broadband satellites, with refueling stations, with both science stations and hotels. Space tourism becomes a major driver at that point. And then out at the Lagrange points, which are these stable orbital areas between the Earth and the Moon, no reason not to have human settlements out there. Not sure what they'll be doing. Will they be doing more science, or will they be doing space tourism? Will they be points of leisure, retirement? I don't know. But that's the vision of the National Space Society, for instance, is to have human settlement in deep space, so-called deep space. On the Moon, we've already talked about the resources there. Tremendous scientific discoveries to be done there. And if we could put a radio telescope and an optical telescope on the far side of the Moon, where they're shielded from electromagnetic and light interference in the Earth, at least in terms of light interference, half the time. Now you've got this incredible astronomical observatory that's stationed on a large rock very conveniently, which can make discoveries really looking back to the origins of the universe itself at that point, because now you're not looking through the atmosphere. And then on Mars, you begin kind of this idea of a second Earth. Terraforming is a whole nother discussion. It would take thousands of years at best estimates, but it could be done ultimately. There's enough water there that you could create a denser atmosphere. Probably never going to restart the magnetic field there because the planet just doesn't want it. It's too old, tired. But you can certainly find ways to build a thriving human economy there. The question is, what's their output? And that's a big discussion.
Right.
There'll be intellectual property. There will be some mining to be done. Really, most of the resources will be for local consumption and getting back and forth to Earth. One more thing I'll add is one thing that Buzz Aldrin came up with that was fascinating. It was called the Aldrin Cycler, which is a spacecraft or possibly even a repurposed asteroid, which you set on a permanent orbit between the Earth and the Moon, or the Earth and Mars, and it just keeps going around and around and around. You make occasional course adjustments, but you don't need to propel it. It's just following a natural orbit, and you have a shuttle that goes from Earth up to that cycle. He calls it the Aldrin Cycler. And when it swings past Earth, you go load up people and supplies, and then you get a free ride out to the Moon or Mars. And then you drop down to the surface of wherever you're going and do your business and come back up. So it's like a ferry. It just keeps going all the time. And the added benefit is it can be massive because you only launch it and build it once. So it's got radiation protection, and it's got ample area for people to spread out and do their thing and relax. And now you get into this kind of 1950s vision of people in spaceships and Barco loungers and bars, and it looks like Star Trek The Next Generation with all that mauve upholstery and 10 forward with the drinks. You can get into a nice cruise ship way of handling interplanetary exploration instead of it all having to be like a submarine in World War II. So there's a lot of visions there, and that's certainly how I'd like to see it play out. It'll probably be, I think we'll be stopped at Mars for a while unless we have a breakthrough discovery. But there have been, in the last 20 years, some things put forth that make it look like we may be able to move at a significant fraction of the speed of light. And if that could be mastered, now you're off to other star systems, other planets, and it gets to be a very exciting conversation.
Awesome. Well, I don't look forward to that because I'll be gone, like I said, but it sounds fun to me. Thank you so much, Rod, for joining the podcast today. I really appreciate that discussion. You've really kind of illuminated the topic even more for me. Like I said, I've always been very interested in space exploration and just the possibilities there. Are you doing any type of public appearances or releasing a new book or anything else that you wanted to spend just a moment promoting?
Well, I had a whole bunch of keynotes going, including the IBM Internet of Things conference in the next couple of months. But as you probably could guess, they're not happening.
That's
At least
true.
In that case, that one went virtual. There'll be some conference appearances later in the year, but they're all sort of up in the air as to when and how.
Mm-hmm.
I do have a couple of books I'm working on. I came out with 4 new books and 3 that I worked on to reissue in 2019. So I kind of burned myself out there. But I do edit Ad Astra, so I'm continuing to do that magazine 4 times a year. And then I've got a book that's a sequel to Amazing Stories of the Space Age. So it's all about either really interesting missions that we didn't learn enough about when they happened, or about missions that were planned and not done.
Mm-hmm.
Some wild stuff like the Germans planning a space station in World War II that was going to have a big mirror and burn down Allied cities and things like that. Just fascinating stuff that I get excited about because I'm a space geek.
Yeah.
And that'll be coming out probably about 6 or 8 months. Till then, it's all about the magazine and my website.
And they can get that on rodpylebooks.com or Amazon?
They can. And I also have a podcast, if you don't mind, called
Sure.
Cool Space News, which is up on iHeart and iTunes and all the other relevant outlets. And I put that out about once a week, just like you do.
All right, great. We'll check it out. Thanks again, Rod. I really appreciate it. And maybe we can talk again another time. I actually had another full page of questions, but I ran out of time. So
I'd love to do that. Just let me know when.
That'd be great. Thank you very much. We appreciate it.
You bet.
Bye. So that's Rod Pyle, where we were talking space today. A lot of very interesting things there. I could really get behind space travel as a leisure activity. A hotel above the earth. Imagine the view from your window. You're sitting there in your hotel room. You look out the window, and then there's the Earth. I mean, that would be awesome. Or he was talking about the Aldrin cycler. You kind of almost like an Orient Express that just takes you to Mars and then brings you back. Those things are all incredibly exciting to me. I think we need to, in my opinion, first things first, protect the Earth. Find a way to put things up there, whatever that approach is. Find a way to put some hardware up there that will protect us in the event that something comes into our near orbit and has a potential to hit us and wipe us out. And once we got that in place, then we can go to the moon. I do think we should go to the moon first, go back to the moon, mine it for all it's worth, get everything that we can get out of it, set up permanent bases there or semi-permanent bases there, set up way stations in between, make that a staging platform to get you other places in the solar system, other colonies, what have you. Put the telescope on the side and take a look at where else we may want to go. I think that there are a lot of things there that we could use back home. And to his point, we never got really to talk about Bezos and Elon Musk much, but Bezos is talking about taking really a lot of the manufacturing and a lot of that blue collar stuff off of the Earth and making that more celestial, space-bound. We're doing all the mining and all the heavy machinery and that stuff in space. And the moon plays right into that, fits right into it. What do you think? If you have any thoughts or questions or comments regarding anything we've talked about today, you can contact us through the Prove Me Wrong Podcast Gmail account. It's provemewrongcast@gmail.com. You can drop us a line. You can also contact us through Facebook, Instagram. It's just Prove Me Wrong. That's the name on both pages. If you just want to hear the podcast itself, you can find us on SoundCloud, Tunein Radio, Stitcher, Spotify, iTunes, any podcast app that you may use. You can find the Prove Me Wrong podcast. Just search Prove Me Wrong and like and subscribe, and you will be notified of the newest episode that becomes available. We're also on YouTube, as you can see right here with the YouTube scroll. Like and subscribe to the YouTube channel, and you'll also be notified when a new YouTube episode becomes available, and you'll be able to see it first. And tonight, our sponsors are Java Remix. Java Remix is a perfect blend of 100% organic Arabica coffee infused with nano-emulsified CBD. Java Remix offers traditional ground coffee as well as single-serve K-Cups in both regular and decaf. And if you aren't a coffee person, it also offers CBD-infused teas and beauty products like bath bombs and body scrubs. As an added benefit right now, for our Prove Me Wrong listeners, if you go online at javaremix.com and enter the promo code Prove Me Wrong, one word, you can get an additional 20% discount off your entire shopping experience. So Java Remix also offers free shipping on all orders over $40, so you literally have no reason not to give it a try. So once again, that's javaremix.com, promo code Prove Me Wrong, and start your day off on the right foot with a great tasting cup of coffee with all the demonstrated benefits of pure CBD. We're also brought to you today by ZendoZones citronella burners from JT Eaton. They are shaped like fearless little tiki gods. So let's Surf and Stan, Hawaiian Howie, and Luau Lily bring the island to your door with ZendoZones citronella burners. ZendoZones uses natural 3% candles and incense cones. They're perfect for patios, decks, backyards, campsites, poolside, and more. You can enjoy the outdoors again, keep the bugs off you. They are available on Amazon and at select Ace Hardware stores. Collect them all today. So for my guest, Rod Pyle, we had a great conversation about space and space colonization, exploration. This is Pete Lieb, and we'll talk to you again soon. Prove Me Wrong Podcast.